welcome back to goldstocktrades.com. Today we have a new and special guest with us, Dr. Jonathan Gluckman, CEO of SIXW Innovations, which can be traded as SIXW on the Canadian Stock Exchange and as ATURF on the OTC. SIXW's had a transformational year in 2019, and they've just gone public this week in 2020. Thank you, Dr. Gluckman, for being here with us today.
My pleasure. Thank you for having me.
Well, for a while I've been interested in mining technology and ways that companies can save money by using new technologies. I've been introduced to this molecular imprinted polymers and would like to learn more about how SIXW Innovations is partnering with some of the top companies in the mining business to improve operations. Jonathan, tell us about your background and an introduction to SIXW and the Ixos technology that is being starting to be used now by the major gold miners.
Sure. So my background, I graduated sometime around 1990 with my doctoral degree from the University of Cincinnati. Although it wasn't in mining, it was more in ergonomics and human systems. And so I've spent the better part of my career looking at how to integrate and make systems better and make them operate better. Eventually, through kind of a long way around, we started designing some communication systems and then looked at developing sensors to go along with those in the Homeland Security area. And so about 15 years ago, I got my first introduction to this science of molecular imprinted polymers. At first, we spent a lot of time implementing these for Homeland Security. We had actually developed some wipes that were made with molecular imprints that detected IEDs. These were used by the United States and coalition forces in both the Iraq and Afghanistan wars. And we've since transitioned making these little more or less intelligent molecules or polymers to be able to capture other things, and specifically to capture gold and silver ions in gold mining. So that's kind of how we got there.
And talk to us a little bit about the work that you've been doing so far on gold separation in America, and also you announced news today of an agreement with Sumitomo, which is a huge, large mining company.
Yeah. So we have over the past few years, we've designed a polymer technology, a bead, that's imprinted to collect the gold and silver cyanide ions out of the leach solutions used in gold mining. And so over the course of those years, we've done, of course, a lot of experimentation and design work in our laboratories. We've patented the technology to do that. And we have undertaken a lot of co-testing with mining partners, all the way through having successfully completed a pilot plant installation with Kinross. More recently, and I guess through the history, we've done testing with Barrick. And during those testings, we were able to validate that we could capture and extract more gold, especially in preg-robbing situations, carbonaceous material that competes with activated carbon in carbon circuits. We did some extensive testing with Agnico Eagle at some of their mines in Mexico, as well as in Canada. As I said, we implemented a pilot plant, ran that for about 8 months at Kinross facility in Nevada. And we've been expanding our ability to reach new customers, and that led us to working with Sumitomo. I honestly don't remember exactly how they found us, but Sumitomo does have mining interests. They're minority shareholders in several gold mines, several of them in the Nevada area. and they've started to introduce us now to some of their clients. And we're really excited to have them as a representation partner. They did an extensive amount of work with us in researching the product and reviewing our testing. And of course, having a company like Sumitomo want to go out and put their name behind us is extremely important. They're a huge multinational conglomerate, and we're very excited to have them representing us.
Yes, it's an exciting thing to see a small cap company partnering and getting the attention of a large mining giant that's been around for many, many years. And you mentioned that these advanced molecular imprinted polymers, they're incredible things. When you look at it, it just looks like beads, like in packaging. But when you magnify it to 500 to 5,000 times, these little beads are able to capture all sorts of metals. And you mentioned that right now we're focused on gold, but in the press release it mentioned some other metals possibly, like we've seen a huge rise in the palladium and platinum group metals and lithium. Could you talk about, does this technology, can it be applied to other extremely precious metals and industrial metals that are very much in demand?
Yeah, so every technology has its place. The science of molecular engineering or forming these molecular imprinted polymers is fairly complicated, and as I said, we've developed a number of patents on how to do that and be able to bring these products to commercial scale. And we've done that with several different products, and this is a continuation. You can design. We have focused on gold and silver because for a number of reasons. One, they're very high valued metals. They occur at when they're mining at fairly low levels, right? So a good gold mine might only have 400 or 500 parts per billion of gold in their leach solution, and so it's very important for the mine to get all of that out. And so we focused on that because even small increments in performance yielded large payback for the company. And so we could address this problem with molecular imprints in a very cost-effective way and enable them to be highly profitable. We've evaluated, for example, things like copper. And while we could do copper, and we've had designs in the laboratory where we've demonstrated that we can do copper, copper is one of those metals that's very, very readily leached and mined using sulfuric acid, for example, which is really cheap, and it's on a huge scale in comparison to gold mining. And so while we could do it for that metal, it's not particularly cost effective in comparison to the world's cheapest chemical, or one of the world's cheapest chemicals being, say, sulfuric acid. We have done designs in molecular engineering for lithium and lithium extraction. It's a very difficult problem to solve because of the size and molecular weight of lithium, but it's also a metal that we've addressed. We haven't done anything in particular in the rare earth space, although those are certainly metals that have the value proposition and that are mined in such a way that would be quite amenable to molecular imprinting. We just haven't paid any attention to those quite yet.
But this is early days, and the focus right now is in gold and replacing the activated carbon. So if you could explain to people that are not in the mining background how this can replace, what activated carbon, how important it is in the mining business,
Sure.
and why the replacement of this with Ixos polymer beads, what the benefits are.
Right. So the great proportion of gold mining is done where a lixiviant like cyanide is used in order to help remove the gold from the rock material. So, most people at the lay level are kind of familiar with sluice box mining, where, people are in rivers and they're sucking up material, and they've got these, little spillways that collect solid pieces of gold, and we see flakes and nuggets like that. But that's a very small percentage of the overall gold mining market. As I said, most of it is, trying to dig a few grams out of a ton of earth. And the way they get that out effectively is leaching it with cyanide for the most part. And so once those gold ions are in the leach solution, in the cyanide solution, the good news is that you can capture them. The bad news is that cyanide isn't particularly discriminating in terms of what metals it will put into that solution. So it likes to take all of the metals out of the earth, and lots of other base metals that become a nuisance for the miner are also put into that lixiviant and need to be removed. So once you've gotten them in there, the conventional way to do that for the last, maybe 70 years has been to absorb the metal ions onto activated carbon. And the goal here is you have to get a concentration level high enough in some solution that you can then turn the gold ions, which are in this liquid, back into gold solids. And in order to do that, people use electrowinning, but you have to have a very high percentage of those gold ions or the metal ions in that solution. And in the leaching process, the process of removing the metals from the ground, you don't achieve those. So some intermediary step, like activated carbon, is used in order to boost up the percentage of these metals in solution so they can be transferred back into solids. Unfortunately, activated carbon also isn't particularly good at discriminating between all of the metals that are in the leach solution, and it gathers a lot of them. So it makes it very difficult in some situations where, say, there's a huge percentage of base metals, copper or nickel or mercury, or in the case of gold mining, even too much silver sometimes becomes a nuisance, and it makes the efficiency of activated carbon go down. And what does that mean? It means that when you pass the leaching solution across the activated carbon doesn't catch it all, and some of that is left. Sometimes it goes into tailings, and the gold company has no opportunity to recover it. Sometimes it becomes a sort of a circular load in the circuit, so leftover gold is pumped back onto a heap leach, and some percentage of that gets absorbed by the rock and is never recoverable, and some percent of it continues to cycle around, but it represents sometimes millions or tens of millions of dollars worth of gold that is in mined. It's in solution, but the gold company has no way of extracting. In addition, activated carbon, it's kind of like pencil lead, so it's not totally soft, but it's not hard either, and it ablates regularly, and it creates fines, and it creates fine powder, and unfortunately, all of that fine powder also likes to collect gold and silver, and so, but it's not able to be removed effectively from the leach solution. So activated carbon can result in quite a bit of lost gold that goes into these carbon fines that, if they're particularly small fines, they can even be put back onto the heap, and they become a self-inflicted preg robbing, if you will. And in a number of the mines that we've worked with, that we've done analytics with, a significant amount of money is lost in these carbon fines. Even recovered fines are not always able to be efficiently have the gold extracted from them, because in some cases they're filled heavily with other elements like mercury, and because they're filled with mercury, they represent hazardous waste, and so some of that loss is not recoverable by the mine. Unlike activated carbon, our beads are made with a very homogeneous set of collector holes, if you will, right? The imprints for the gold and silver ions. And so fewer of the base metal ions are collected on our bead because they don't fit into the collection sites. And so they get rejected, which means that we get a much higher purity of gold after the extraction from the leach solution, which means that the mine pays less in final refinement. In addition, our beads are much harder and much more stable than activated carbon, and so we don't have that kind of attrition into fines that represent significant losses for the gold mining industry. And also, the process of removing gold from our beads is much faster and less complicated than removing the gold from activated carbon. And so we end up with the ability to run what's called the dilution or the desorption and recovery in the mining vernacular. We get to do that much faster. So we've actually been able to demonstrate on site with our pilot plant that we can run as many as 6 elution cycles in the same period of time that it takes to run 1 elution cycle for activated carbon. Why is that important? Because the desorption and recovery stage is the most expensive to run for the gold mine, and it is what dictates the size of the plant. So it's very capital intensive. We can end up building a plant that's capable of doing the same amount of recovery at a sixth the size, which means that the capital expenditures to utilize our technology and then the associated operating expenses are also lower. So we get more recovery, more gold, less gold that's cycling around in solution because we extract very efficiently, higher purity, and lower costs.
And that's really what these miners have to deal with, these producers and near-term producers, is being able to look at ways to save money and provide that in either dividends or, or to help expand and look for new resources. So these miners that are producing shouldn't waste this gold, and they should look at this and contact 6Wave. You can go on their website, SIXW.CN. To get more information. They just started trading this week on the CSE as SIXW, trading on the CSE, and as ATURF on the OTC. Please contact them and check out the website. It's going to be an exciting year. They've just partnered, you heard it here, with Sumitomo to start marketing this technology. It's just at the ground floor, just starting, being used at the pilot scale and now being rolled out. Thank you, Dr. Gluckman, for being here with us today and for giving us an introduction to this new and exciting company, 6Wave Innovations. And we really appreciate you being taking the time to talk to us.
My pleasure. Thank you again for the opportunity. We look forward to hearing from more folks and rolling this out, and I hope we'll have an opportunity to speak again as more exciting things are on the plate for us.